Hi, I will show you the circuit that I built to create split plus and minus 6 volt split rail supply from 15 volts. So the basic idea is that we will get plus 12 and 6 volts by using two linear voltage regulators, and we will use the plus 6 volts as our 0 volt. So the 12 volt will be like 6 volt, and the ground will be like minus 6 volts. As long as your supply and the other things are isolated and you are careful, this is quite good for some of my applications. Let's check the circuit now. I used LM317, a linear voltage regulator. So I just connected 330 ohm resistor here and a 5 kilo ohm single turn trim pot here. So we will set the output voltage of this regulator to plus 12 volt, and the same thing applies to this one. We will get a plus 6 volt here by configuring this trim pot, and I also put 100 nanofarad ceramic disc capacitors for decoupling purposes, and this is the logic. So I built the circuit like this. This is the PCB that I built for this schematic. So these are the two LM317s, the decoupling caps and the resistors, and the two single turn 5K trim pots. And this is the back side of the PCB if you want to look. You can create easier circuits like Zener split supply or other circuits than this, but with this circuit you will get approximately 6 and 12 volts with some acceptable noise. Maybe some of you noticed that there's a problem with this circuit. Now when we check the block diagram of the LM317, we can see that the chip can only source current through its output, but we can push current back into the chip. So when we use this, we can't push current to these chips. So for example, if we have plus 10 volts and we connected it to plus 6 volts, let's say, we will not be able to push current into this LM317. So the voltage here will be dropped, determined by the resistor here. I noticed this problem when I built the circuit and tested it with some load. This is my first time using LM317. So to fix that, I came up with this idea. I connected a basic push-pull buffer configuration to the both pins. So these are the same buffers. Just this basic configuration, one NPN and one PNP transistors, their emitters connected together, and the op-amp. So as you know, op-amps try to make their non-inverting and inverting input the same. So this op-amp will do whatever it needs to make 6 volts here. So here, so we will get plus 6 volts and plus 12 volts at the output, and we can now push and pull current because of these transistors. So I used LM358 for the op-amps, and S8050 and S8050 NPN transistor, S8550 PNP transistors. You can use probably any kind of general purpose transistors for this case, BJT, and op-amps, it doesn't matter for our circuit that much. So because I built the circuit, I made a module to connect to this for this purpose. It's looking like this. It's just this part of the circuit. We can connect it like this to the circuit, and we can power it by the ball jacks. Now we can get -6 volts from here and the ground, and +6 volts from these or these two ports. Now let's check the voltage output at the circuit. So when we use the middle pin as the ground, as our new common, we get +6 and -6, as you can see, and this stays the same when we connect the load. Now I connected a load and it's still +6 volts and -6 volt. Now let's do some measurements to measure the output noise of this circuit. So I connected a load and I'm measuring the plus 12 volt output of the circuit, and let's check the output. As you can see, there are some bursts with around 40 to 40 millivolt peak to peak, but other than that it looks quite okay. As you can see, I don't know if these are caused by the circuit or the some other things around me, but the noise can change with time or the temperature, or when we use these +6 and 12 volt outputs, the output noise can be different. So as I said in the beginning of the video, this is not a precision circuit, but it should be great for quite some applications. So this is the circuit. I hope you learned something. Please comment your recommendations down to the comment section. Other than that, thank you for watching.